Okay, so what I've got here is the data examples for chapter 4. If I go into the computer dice exercise here, I hit index, boom, I've got myself a dice. It's a little bit, won't quite fit on this screen. Oh, that's so sad. Yeah, I may have to zoom out a bit. So I just do. I zoom in to make things bigger, you know. And now I'm zooming out again. So there you go. What you do is you press the roll button like this, and you roll a number. And if you press it again, you roll another one, and another one, and another one, and another one. 4, 4, 1, 6, 5. When you press it, and if you did a bit of studying, you'll probably discover, well, I hope you discover, that actually it does give numbers between 1 and 6, and you tend to get a reasonable distribution, as many 1s as 6s, and that kind of thing. So that's what we're making. How do we make it work? Question for today. Well, I'm going to do some playing around in the console, and then we'll discover how the random numbers in JavaScript actually work and how we can use these as the basis of a dice program. Sound like a plan? Well, if it doesn't, I'm going to do it anyway. Press the button to bring up developer view. There it is, nice and big. That's caused me problems before. Okay, so I can now type in commands to JavaScript to make it do things. Now, I talk in the book about math as a library followed by dot, and now it suggests all the things you can do in math, and there are a lot. Some of them make sense, some of them to me don't, but the one I'm interested in is the one called random. So if I type R-A-N, it'll suggest random. This is a function, so I'll have to call it to get a number back, so I'll put the open and close brackets on the end to mean call this function please, hit return, and up comes a number, and that number is random. If you see the same number coming up, my goodness, I'll be surprised. I'll do it again. Different number, different number, different number, never the same twice. If it is the same twice, there's something wrong with the universe, well, that might be true. You may have proved it, but now you should see, if you do this, you will see numbers that come up which aren't these, which is absolutely fine. Now, this is a number between 0 and 1, but very important, we'd never get the number 1. So if I multiply this number by 6, say, I'll get the numbers 0, 1 to 0 point something all the way to 5.999999, but never 6. So if I take my number and multiply it by 6, like that, I'm going to get a number that looks a bit like a dice, except for the fact that we never get a 6, and sometimes we get these numbers here, 0.67, which is less than 1. So what we have to do next, really, we don't want these fractional bits. We've got an integer dice, we want an integer number. And we've talked about whole numbers. Whole and integer tend to mean the same kind of thing. A whole number doesn't have any fractional part. It's whole as it is, no fraction bits hanging off. Now it turns out that JavaScript has a built-in function in the math library which will take a number and throw away the fractional bit. And it's called floor. And if I give it 1.999999, I knew there'd be a flaw in the plan. Oh, I'm on a roll. What a day. So if I do that, take 1.999999 and throw away the fractional bit completely. So 1.999999 goes to 1, which is a bit vicious, but there you go. Floor, it's defined to throw away the fractional piece. You might want to round things up. If you want to do that, there's a function called round, which will do that. If I go, this isn't in the book, but it's a bit of bonus here for people watching it on video. Math.round 1.99999999. Extra 9 makes all the difference. Gives you 2. So that one, the actual process you use is not hard. You add 0.5 and then floor it. So if you have 1.6, say, you add 0.5, that's 2.1, floor it, it's down 2. So rounding isn't particularly hard. It's just nice to have them both there. But we're going to use floor because floor is what I want. And so if I go math.floor and math.floor, here you go. And I'm just going to use some cunning editing here. I'm going to take the output from a call of math.random, which gives me a number between 0 and 1, remember, but not including 1. I'm going to multiply it by 6. Then I'm going to floor it. boom, I get a number which is an integer, and the number is between 0 and 5, because we're never going to see that mythical 6 because the random value is never 1. So I get a value between 0 and 5 with a nice uniform distribution between them. So if I do this, these look a bit like dice, except for the fact I'll never see a 6 and I'll sometimes see a 0, although I'm not seeing one just at the moment. In fact, I've done it more than 6 times and I haven't seen a 6. Oh, there you go, there's a 0. Oh, that's a relief. Now, we don't want zeros, but we do want 6s. And so what you do is you take this result and you add 1 to it. Boom, boom. So now I've got a dice. And that actually, that little bit of math, if you can make sense of it, wonderful. If you can't, here is it in slow motion. What? No, don't do that because that would just offend people. Math.random gives me a number between 0 and 1, but not including 1. Very important. Multiply it by 6 and I get a number between 0 and 5.999999. Throw away the fractional bit and I get a number between 0 and 5. Add 1 to that and it goes from 0 to 5. It goes from being from 0 to 5 to being from 1 to 6. Hey presto, I have a dice. So if you want to hold that thought in your head while I press this button here. Boom. Now this is actually looking at the code, and it's a bit of a mess because I've zoomed in so much. So what I'll do is I'll just zoom out a bit, which I can do here. I think I did it before. Oh, I did it. Go you won't go. That's it. So it's a bit smaller now. That's nice. Now here's my nice map of the. I love this map of the thing. And if I look in here, this is the JavaScript program. If I click on here to open this up, we can see that, oh, look, there it is. That is the working component of the program, slap bang in the middle there. It takes the math.floor thing and does exactly what we said and works a treat. As we can see, it makes a variable called spots, which is a good name for it. I like having a program with a variable called spots in the middle, and it sets it to this random number, and then we put that on the end of a message. So we say the word rolled followed by a number of spots, and then we output it. So this stuff is the actual guts of the program, and the bit that makes it really fly, the bit that does the clever stuff, is this math.floor, throw away the fractional bit, of a number between 0 and 5.99999, and add 1 to it to get me up to 6, and then off we go. Now you can play with this. You can play Monopoly if you want to do. You could play Monopoly with this, but you'd probably want 2 dice to do that. See if you can modify this program to display 2 numbers rather than 1. How about that? That would be a good thing to do, wouldn't it? But in terms of what we're doing, we now know how to make random numbers. Second question, it's in the book. How do I make a number between 0 and 1 and 20? What I can make that happen in this program, making a single change to the program. How do I make it go between 1 and 20? Well, this is the 6 that multiplies the random number between 0 and 1 to get me my range, my range of 6. Replace it with a 20, and bang, I'm in there. So you can make this whatever kind of dice you like, as many sides as you want, and it will just multiply up and then go wonderfully. So that's that, and now you can go back to the book.